To begin our afternoon sessions, I'd like to introduce Mr. Fred Kruger, who is the director of the Orthodox Fellowship of the Transfiguration, and also for the, tell me the National Religious Coalition on Creation Care. That's, I think, probably fair to say where the bulk of your time goes, because that's they have budget, we don't. And so Fred has been a dedicated crusader on behalf of God's creation for decades, and was aware of and involved in this work long before most of us woke up to any of the issues whatsoever. It is a privilege and an honor to have him as the director of our organization, and it's a privilege and honor for me to introduce him today.
It's a pleasure and an honor to introduce this afternoon one of the preeminent scientists in our world today. But you know, no person stands on just one outstanding quality. There's always a multiplicity of qualities. And I just learned, perhaps 5 minutes ago, that James Hansen is also an icebreaker. He's called an icebreaker by people in this area, not only because of his pioneering activities, because last year in January, as part of a benefit, he jumped into the ice-filled Chesapeake Bay in the Potomac River as a statement of willingness to do anything to publicize the significance of climate change. But you know, there's also another quality that's tied into this. Do you remember? I want to exemplify a quality. About 30 years ago, Alexander Solzhenitsyn came to America. And he gave a memorable commencement address at Harvard University. And you know, he said, there is a quality, an important quality that is missing in the American character. Do you know what he identified as that missing element? It's courage. It's a willingness to speak out and to tell the truth in the face of contrary views. And James Hansen has done that. He's gone to the White House. He spoke to Congress before anyone else was willing to say, climate change is happening now. And that's an example for everyone, because there's a manufactured denial of climate change for financial reasons, and we need to have that courage. But there's a further quality. As His Eminence mentioned in his talk, there is a unique kind of compassion, a kind of charity, an intergenerational charity, a concern for the future. And so James Hansen in his book wrote, Storms of My Grandchildren. And so there's many qualities to develop to achieve preeminence. And with that, I simply want to introduce one of the foremost scientists and icebreakers of our time, Dr. James Hansen.
Thanks, Fred. Thanks very much. That's the most unusual introduction I've ever had. Yeah, climate change is not only happening, but we now have a crisis, which is not easy for people to recognize. The weather is really great. You know, this is another planet. I spent 10 years of my life studying the planet Venus. This is an image taken with a little 1.5-inch telescope, which I had proposed to be included on the Pioneer Venus mission. And it took this image as a spin scan spacecraft and measured properties of this veil of Venus that shrouds the surface of the planet very precisely, allowing us to know what we're looking at. And this is sulfuric acid cloud. It's a dead planet because of its proximity to the sun and initial atmospheric carbon dioxide concentration. The planet heated up enough to cook all of the CO2 in the crust into the atmosphere, and it now has a temperature of several hundred degrees, hot enough to melt lead on the surface. Well, while that experiment was going on, I became acquainted with some interesting facts about this other planet, which is an incredible planet with spectacular life on it. More than 10 million species live on this planet, the only planet that we know that harbors life. But we realized in the 1970s that the atmosphere of this planet was changing, and that made it a much more interesting planet than any other planet. Because people live here, we would like to know the effect of this changing atmospheric composition. Well, so we worked on this problem, developing models to simulate the atmosphere and climate of planet Earth. And after several years, produced a paper that we published in Science magazine in 1981, in which we pointed out, based on weather stations around the world, that the planet had warmed up by 0.4 degrees Celsius in the previous 100 years. And that was consistent with what we calculated as the expected warming due to the increasing carbon dioxide from burning fossil fuels. And we predicted that the 1980s would be the warmest decade in the history of instrumental measurements, that by the 1990s, the warming would be so large that it would rise well above the natural level of variability for global average temperature, and that in the 21st century there would be creation of drought-prone regions in North America and Asia, beginning of the melting of the Greenland and Antarctic ice sheets with the rising sea level, and opening of the fabled Northwest Passage. Since then, all of those things have, in fact, occurred, and we've reached a point where it's become clear to the scientists that we have a crisis, but it's not obvious to the public because the Earth, the climate system, has a great deal of inertia. It doesn't respond quickly as you change the composition of the atmosphere. Because the ocean is 4 kilometers deep, the ice sheets are 3 kilometers thick, they have a lot of inertia. But the problem is, that inertia is not our friend. It means that we've only observed about half of the response due to the gases already in the atmosphere, and there's more in the pipeline because of the infrastructure for fossil fuel use. And there's the danger that we can push the system beyond tipping points where we lose control. Once the ice sheets begin to disintegrate and go into the ocean, then you can't stop that by changing your emissions. Let me just mention a few of the impacts of this changing climate. And I focus on those which are irreversible. If we exterminate species, then they're gone forever. Likewise, if ice sheets disintegrate, it took tens of thousands of years for ice sheets to build up from snowfall piling up. So we are putting stresses on different species on the planet in many different ways. But these combine with the fact that we are now beginning to see the shifting of climate zones because of the planet getting warmer. And those stresses can combine to exterminate many species. I like to use this example of the monarch butterfly. You know, I like the Native Americans and the Canadian First Nation people, the fact that when they do their blessings, they bless all of the life, you know, even the snakes, everything. This species is a remarkable, this is an insect, but it's a remarkable insect which migrates all the way from middle of Canada to the middle of Mexico, where it hibernates for the winter in a small mountain area on fir trees, and somehow is able to find its way back to that very small region in Mexico, even though it takes about 4 generations of this insect to make that annual trip. The female will lay eggs on a milkweed plant, and that's the only plant that the larvae, the caterpillars, can eat. And then they will crawl off and miraculously change into this acorn-like chrysalis. And then after a couple of weeks, the chrysalis opens and a remarkable butterfly emerges. Well, when my wife and I were younger, we could see 10 or 12 of these monarch butterflies at a given time in our field. Now the number has been decreasing, mainly because of Roundup, a pesticide, a herbicide that farmers use to kill weeds, but it kills milkweeds. So I thought it would be useful for my grandchildren if I introduced them to nature by having them help me plant milkweeds for these monarch butterflies. 2 years ago, in 2011, I took this photo of this broken wing female butterfly in our backyard, so I could identify her from her broken wing. And she was the only butterfly around at that time. And I came off actually to a meeting in Washington. I don't remember if it was also a church one here, but there would happen to be a hurricane at that time, and so I stayed a few days at my sister's house in Washington. But by the time it got up to where we lived, it was just a heavy storm. We got 8 inches of rain, but very high winds. And I thought, well, this butterfly, and by that time she had a number of larvae, the caterpillars you can see eating the milkweeds. So I thought they would get washed away by this 8 inches of rain, but I came back and that butterfly was still there, and she stayed around for a few weeks. And then some of the chrysalises were in the privet, and you can see 2 butterflies just emerging from the chrysalis in the upper right and lower left corners. One of them was a male, and one of them was this female. And so then they set sail for Mexico. But there was a huge drought in Texas, so I didn't know whether those monarchs are going to make it to Mexico. Well, I wrote an article about that broken-winged butterfly, and a scientist in Mexico sent me some photos. He specializes in the monarch butterfly. And here is a branch of one of those fir trees covered by thousands of these monarch butterflies that had made it. However, the number that made it that year was reduced 30% from the year before, and probably in good part to that drought. That's the Mexican scientist's son looking up at these butterflies. And what they saw was that the trees are now under stress because of the changing climate, because of the continuing drought, shifting climate zone. So he is trying to persuade the Mexican government to plant trees higher up the mountain where the temperature is more appropriate. But he calculates that by the end of this century, if we keep burning fossil fuels as we are, that the mountains won't be high enough for this. So it's very hard to imagine that you could get these monarchs to find a different place to migrate to. And by the way, the next summer there was a bigger drought in the United States, and the number of monarchs that made it to Mexico was reduced another 59%. So the number is now 7% of what it was 25 years ago when they started counting the butterflies. And this summer, I saw only 4 butterflies. One male came and landed on the butterfly bush, but he flew around the yard for several hours and sat in the grass and sat on a privet bush. So I don't know. I'm now wondering whether these monarchs are different than, when I was a boy, there was another species that was threatened. That was the largest bird in North America, the whooping crane. And it got down to only 23 birds left in the world. But then people got very concerned about this and tried to protect them. And when I was a newspaper boy delivering this Omaha World Herald, at the bottom of the front page, they would keep count of how many birds had arrived in Texas where they overwintered. And it slowly increased. And now there are about 400 or 500, I think. So they may have saved that species. But in the case, those birds traveled in pairs. Now, in the case of the monarch butterflies, that's not the case. So it seems it could be a very nonlinear problem. And I wonder if that male was looking for a female. He wasn't finding one. And he eventually got chased away by these big yellow butterflies. I forget what they're called, a tiger or something. But in any case, I didn't think I was introducing my grandchildren to witnessing an extinction, but I'm just afraid that that's what's happening. That was people trying to guide these birds to a different winter nesting ground. But there are lots of species that we are putting under stress. Coral reefs are the rainforest of the ocean. There's more than 1 million species associated with coral reefs, and we are losing coral reefs at a rate of more than 1% a year because of ocean warming, which causes the coral to expel their symbiotic algae, and acidification of the ocean, and other things that we're doing. So that's one of the problems with global warming. Another is sea level, which is beginning to accelerate. The rate is now 3.2 millimeters a year, which is about 14 inches in a century, which is not yet disastrous, but the rate is accelerating. And we know that the last time the Earth was 2 degrees Celsius warmer, sea level was at least 5 meters higher, and probably 6 to 8 meters higher. When it was 3 or 4 degrees warmer, it was 15 to 25 meters higher, which is more than 80 feet. So if we allow warmings of this level, we can't say which generation is going to suffer the full effects, but we're guaranteeing that some future generations will, because the fossil fuel, the carbon stays in the surface climate system for millennia. We can't burn all of that fossil fuels without guaranteeing disasters. Well, the melting on Greenland fluctuates with the weather from one year to another, but the area with melt is increasing with time, and the water goes to a low spot on the ice sheet, burrows a hole in it, and goes to the base of the ice sheet where it lubricates the ice sheet, and it speeds up the discharge of giant icebergs to the ocean. We now have precise measurements from the gravity satellite, which allows us to measure the mass of the Greenland ice sheet and the Antarctic ice sheet very precisely. And we see that, of course, it gets heavier in the winter as snow piles up, and then it loses mass in the summer. But overall, it's losing, both ice sheets are losing mass faster and faster. So An update here for Greenland shows that last year Greenland lost 500 cubic kilometers of ice, and that's now becoming the major contributor to sea level rise. And the distribution of the climate always fluctuates from one year to another, but back in the last century, the anomalies formed a nice bell curve distribution. Well, because of the warming, the bell curve is shifting to the right. So the extreme hot events that used to occur a few tenths of a percent of the time are now occurring several percent of the time. And those now cover a significant area in any given summer. You can't say which areas are going to have the most extreme climate. It fluctuates with the weather patterns, but we're getting more of that. And where you do get a high pressure system stuck, you get not only higher temperatures, but more extreme drought, more extreme fires that burn hotter. The number of those is increasing with time. But a warmer atmosphere holds more water vapor. So at the times and places when you get rainfall, you can get more extreme rainfall and greater floods. So the 100-year floods are now occurring much more than once every 100 years. And the storms that are driven by latent heat, by water vapor, because a warmer atmosphere holds more water vapor, and that's the fuel for storms, the strongest storms can now be stronger. That warm Atlantic Ocean contributed to Sandy remaining a hurricane all the way up to New York City. And thunderstorms, tornadoes, tropical storms, all can now be stronger because of the greater water vapor. Now we know that the planet is now out of energy balance. When we add CO2 to the atmosphere, that absorbs heat radiation. So it's like putting a blanket on the planet. It reduces heat radiation to space. So temporarily you have an energy imbalance. You have more energy coming in from the sun than going out as heat, and therefore the planet must get warmer until it restores that balance. We can now measure that energy imbalance because most of that energy must go into the ocean. The atmosphere is very thin. It has a very small heat capacity, but the ocean is very deep, has an enormous heat capacity. We can now measure that because we have these floats distributed around the world ocean. They dive down to a depth of 2 kilometers, making measurements, including the temperature, and then they go back to the surface and radio the information to a satellite. What we find is that the heat content of the ocean is continuing to increase at a rate of about 0.6 of a watt per meter squared, which, as I said, means that earlier, it means that we've got almost as much warming in the pipeline as that which has occurred. And those measurements were made during the period when the sun was at its weakest level during the entire period that we've been measuring the sun. And yet, despite the sun being unusually dim, there was more energy coming in than going out. And although the sun is a variable star and can vary by 1/4 of a watt, the average over the solar cycle is reduced about 1/10 of a watt in this weak current solar cycle. That 1/10 of a watt compares to the energy imbalance of 0.6 of a watt. So obviously, it's a weaker effect than the human-made effect. And you may hear that, oh, global warming has stopped in the last 15 years. So that's oops, what did I do? I guess there's no laser pointer, but you can see that the temperature on this left-hand scale has fluctuated around. There is a laser pointer, but somebody else is pointing it. Audience participation. Okay. Okay, so the temperature, you know, they say, oh, it's not warming anymore over these last 15 years. Well, that's because 1998 had the warmest El Nino of the century, and that caused the temperature to jump 2 standard deviations above the trend line. And but if you average the temperature over 11 years to take out this effect of this southern oscillation, the El Nino-La Nina cycle, and to try to take out the solar cycle, then you see that the temperature is still going up. And if you look, and the reason that it appears to have leveled out is because over that since that huge El Nino, the last 5 years have had 2 strong La Ninas. But if you compare the global temperature during those last 3 La Ninas, you see that the temperature has continued to go up during the cold cycle. And during the warm cycle, even though these are weaker, the temperature has also continued to go up, although somewhat slower. So the planet, but we know the planet has to continue to get warmer because it's out of energy balance. If there's more energy coming in than going out, then it's going to keep getting warmer. What that means is that we can't burn all of the fossil fuels without destroying creation.